Hi everyone, thanks for joining. So today I'm gonna speak about the evolution of generative AI. So I'm Sadid Hasan. I'm an AI lead at Microsoft. So I have over 2 decades of AI research and product development experience, and I currently lead the Office M365 CoPilot development in Microsoft AI development and acceleration program based in NARD Cambridge site. Before Microsoft, I was an executive director of AI at CVS Health, and before that, I was at Philips Research, technical lead of the AI group. I have lots of publications and patents in natural language processing and machine learning, as I have studied in this area for a while. Um, yeah, so feel free to connect with me in LinkedIn, and yeah, let's get started. So, as you all know, the generative AI is transforming how we approach work, creativity, and collaboration. And you can see that there is lots of use cases for it in various industries, in government, for complex data analysis and pattern analysis, in government functions, automobiles like self-driving cars, in healthcare. As I mentioned, that I had been worked on the healthcare domain for a long time. So therefore, yeah, there are lots of impactful use cases in healthcare, like clinical diagnosis inference, and lots of multimodal use cases in terms of understanding the patient history to be able to figure out what's going on with their health and where they need support in terms of treatment plans. Financial domain definitely is also one of the early adopters of AI, and in terms of fraudulent behavior detection and things like that. Gaming industry is also propelling nowadays with generative AI in terms of making the user experience and the gaming experience more and more useful and intuitive for the players. And in various businesses, as you can think of, there are lots of business functions that are becoming efficient and effective using generative AI. Education sector is one of the most another impactful domain, similar as healthcare, where both students and teachers can be benefited from generative AI. Manufacturing industry is one of those industries where I remember that with people in the researchers in AI domain, we thought that that would be disrupted by AI first, but still the robotics and that type of innovation still evolving, and feels like that okay, it's catching up with the generative AI in other industries. So this is just to give you an overview of the impact of generative AI could have broadly. Now, taking a step back, since I'm speaking about evolution of generative AI, because the main goal of this talk is to connect the dots between the past, present, and future trends of generative AI, so that you can have an understanding of where things are going, where we came from, so in a way that would be very beneficial for our product development, if you're interested in developing AI products and solutions. Now, taking a step back, AI, the definition is it's a domain in science and engineering where it's intersecting. The idea is to create intelligent systems that can perform tasks that normally require human intelligence. So it's kind of mimicking how human can act and think. So now, how the machines actually do that is obviously using data. So data is the information that the AI systems use to learn. So lots of data nowadays are available to train generative AI models, like large language models. So that's also you know uh, uh, very much beneficial in the propelling of this type of algorithms. Now, how the machines actually do that using algorithms? So algorithms, as you know, is a set of steps and rules, and the processes that are used to solve some specific problems in a domain. So I'll cover more details about large language models and the generative AI problem domain in the later slides. But the idea is that algorithms are used to navigate through the data to identify the patterns, and once that is done, then we get to some models that are built, and that the models are actually the representation of the AI systems that it could learn from the data and from the algorithms that is used to perform some tasks. Now, if you think about the history of AI, so it was first coined in 1956 in a Dartmouth college conference. And since then it has seen ups and downs in terms of the progress, and problem solving and the history. It has gone through lots of challenges and definition changes and complexities that I'll cover in few slides later. But a brief history is like, over 40 years we have seen the advent of machine learning terminologies, where we have seen in 90s that like how we can build machines that can learn from data, and then it can actually improve over time based on some evaluation metrics where we can assess the performance. And in 2010, around that time, and the deep learning terminology came into the picture, where with the advent of more data and layered architecture, where we saw that using more layers, more data actually helps in terms of coming up with more performant models. And through that progress, we have seen in 2021, with the advent of ChatGPT, we were becoming more familiar with generative AI. Now, I just want to call out one thing, is that these dates are really where general public are more aware of these terminologies. But even before that, we have been working with generative AI for a long time. So this is kind of the picture of how it comes down. So this is generative AI is basically a sub field of AI, machine learning, and deep learning. Now, in terms of taking a little bit further step back, how we actually came here, if you want to really connect the dots with the past. So if you think about it, like the data collection really literally started at the invention of the printing press in 1400s. And at that time, what happened is, like people started encoding and writing and publishing books, and that actually transformed the mindset of people in Europe at that time. And since then, the data collection started in the form of books and publications and papers and things like that. In 1800s, a big jump from there. So as people are accumulating data in the form of writings, then during 1800s, what happened is, Ada Lovelace, she wrote her first computer program. So she was an assistant of Charles Babbage, who invented the first computer. But at that time, this was not really appreciated, because people couldn't really make sense of why we need to um, come up with logical programs and what's the benefit of it, because Charles Babbage's thought was use of computers as computational engines, like same as calculations or advanced calculations and things like that. So that was not really appreciated. But later on, we know that that was really the start of the journey that we see right now in terms of programming languages and interacting with computers for advanced solutions. In 1950s, the as you all know, that the operating system, the PC revolution started. And with that, what happens is, people started interacting with computers, and they started understanding the benefits of it. And at that time, and before that, the idea was that, how can we get the computers to all desktops. So that's the revolution of the personal computers. And the next 40 years, AI and machine learning saw lots of ups and downs, as I mentioned before, simply because of computational complexities and the need for lots of data, which was not available yet, because data was kind of siloed in personal computers. But when the internet came in 1990s, at that time, people started interacting and collaborating and communicating data through internet protocols, and that actually started the revolution of data sharing and creation, um, and also start of the new AI revolution. Now, in 1997, as based on that revolution, when we saw that IBM came up with Deep Blue, and at that point, people started thinking really that if machines can beat chess champions, so that means really there is some some benefits that are lied in AI based technologies. And afterwards in 2000s we have seen rise of social media platforms. So basically these are propelling more data sharing and communication. People started communicating within these platforms, but at that time people started realizing that okay, that there has to be something that needs to store all this data with more reliability, and so that the data is not lost, and replicability and things like that. So that is the point where cloud computing revolution started, so that data can be stored in the cloud, and people can basically borrow the computation from the cloud for their need, and people can start sharing data and the resources that are needed for their compute and memory from the cloud. Now these all led to the smartphone revolution in 2007, where the idea was how can even the computers can be made more accessible. And through the advent of that, all of those things started progressing super fast in terms of computational complexity, data collection, internet speed, and things like that. And as a result, you can see that databases have been created, that were huge, that led Watson win the Jeopardy in 2011. And as you can see, based on the progress of this, we can say that the next AI revolution started with the start of using deep learning based algorithms in 2012, where ImageNet came on, and convolutional neural networks based algorithms showed that human level performance can be achieved for object recognition tasks in computer vision. So that is where people started to again think that AI can really help. But still, those days were about like solving simple tasks like computer vision, object recognition, and things like that. But the next 10 years or so, we have seen lots of algorithm development. So this is the area where I also propose various new algorithms for reinforcement learning, for text summarization, complex question answering. So this was based on my PhD work. Then sequence to sequence modeling. So these are all representational learning, that how to represent all those sequential data, encoder decoder based approaches. So these are the approaches that are the backbone of generative AI based systems, where you encode lots of data points into high representational data, and then how to decode them in a way that you really solve some tasks in a generative or discriminative way. So recurrent neural networks, attention-based methods, transfer learning, multitask learning all came into the picture during that period. Then ResNet is basically collection of more layers within the convolutional neural networks, and VGG nets. Then AlphaGo came for the Go game, where it beat the human champion there, generative adversarial networks, transformers, which is the attention is all you need, the paper that is, again, transforming the generative AI models. Elmo, BART, GPT, all these base language models started to develop. So these are the models that are all based on advanced sequence to sequence and attention based models that showed that really what you need is some sort of attention. You don't really need to encode the entire sequence, because the sequence to sequence based machine learning are actually the backbone of understanding the full context, because that is needed for really generating tremendous amount of data that we can see right now. So with that progress, we have seen similar progress in the computer vision domain with the advent of daily stable diffusion models. And when ChatGPT came into the picture for conversational AI systems like question answering systems, at that moment, the general population really started realizing the tremendous benefits of generative AI at that point. And as you all know, that since then we have been in the journey of progressing more and more different models are coming from OpenAI, and with collaboration with Microsoft, we are in leadership role in this area, where GPT-4 various copilots we are developing, like Bing Chat, GPT-4 Vision, and now GPT-4o came into picture. Daily 3 multi. So various of these models are actually coming into picture from various open source communities and startup communities. and all are leading towards the benefits of generative AI across various industries. Now, if you have seen this trend, so one thing I just want to highlight is that the definition of AI kept changing over the years, and it became more complex and complex. So, as I mentioned, that in 1950s, when Alan Turing came up with the Turing test, so that at that point the idea was that can the machines actually think like a human, right? So that was a very simple definition. Can the machines act like humans? Now, Richard Feynman also had a famous answer to this question: is it really possible, right? So he as you know, he was a famous physicist, so he gave the answer that this is actually the main consideration here. Can machines think like human or not? So the answer is no, maybe because it cannot essentially do as much as human. Either it could do similarly as humans, it could be less performant, or it could be more performant. So that was kind of the prediction he made. So but at the same time, one thing we need to remember is that the limitations of humans are also being learned by the machines, because the data is coming from lots of human generated data, right? So that's also being encoded by the machines. Now, if you've seen the progress of the definition of testing, so in 2012 there was a Winograd schema challenge that by University of Toronto. So they also came up with the idea to test that if a machine can do common sense reasoning or natural language processing at that time, like this. So, for example, this sentence: the trophy wouldn't fit in the brown suitcase because it was too big. The question is, what was too big? It was it the trophy, or was it the brown suitcase, right? So if the machine can actually identify this, then it was assumed that okay, the machine is actually learning very well and acting as as well as the human. But later on, if if you use Chat GPT or Bing Chat or any other copilots, you see the generative AI can actually solve these challenges very well nowadays. So, and that's kind of this is kind of to show you how the complexity is changed and the definition changed, right? So in 1997 people thought, okay, if the machine can beat a chess grandmaster, that is AI. But once that was done, so people nowadays we all play with chess, computers and things like that. We feel like okay, this is very much integrated, and we don't feel like okay, this is AI anymore, right? So so similarly, object detection, once it achieved human level performance, that is not considered as much performing AI as much as we think is AI. By AI, what we mean, right? So the definition kept changing with AlphaGo. So it's basically we are pushing our North Stars more and more and trying to solve more complex problems. So I don't want to go more details on this, but nowadays we're focusing more on how to solve complex mathematical, biological, chemical problems that the researchers do, right? Using these kind of generative AI models. So, but now again, to summarize, the main innovation that happened with the generative AI and after ChatGPT is that it enabled people to use this kind of powerful models using natural language, because before that we had to work on various programming languages to do some tasks and work on computers. But nowadays you can simply use any natural language, especially like the models that are trained on English. They're more powerful, and we are working more and more on other multiple languages to make it more seamless. Now, how that it happened? Again, to summarize, the in 2010, the people at that time started working on translation-based problems, where this was like machine translation community. So, and you have seen Google Translate, Bing Translate, so that used to translate text from one language to other language, so that achieved near perfect translation. Then in 2014, the first language model came into picture that started meaning, mastered the meaning of words and the context. And then during this period, there was lots of large language models, but they were not powerful yet until ChatGPT was released in 2022. Now, there are various verticals, as I mentioned, that it's not only text based, right? For generative AI, so at least there are six verticals. So text generation can happen, and then image generation. So there's computer vision. Then audio is also another key modality in this domain. Then video, 3D, and code generators. So, for example, GitHub Copilot, you can generate codes very easily. Now, just to highlight again that what happened through this push is that a paradigm shift. So when I was studying, in machine learning and building AI models for my PhD thesis on complex question answering and text summarization. So at that point, everything was task specific. So we had to create models that are focused on specific tasks. So, for example, summarization, named entity recognition, question answering, or generation. So we used to have that task. We used to have specific data for that task, and then we used to train machine learning models on that specific data, deploy it, and then test it. But with the new paradigm of foundational models, where the idea was that can we leverage the vast amount of data that we can get from web or anywhere else, and that is kind of could be used by self-supervised machine learning, right? So you don't need explicit labeling data, which was needed for task-specific models. So large language models actually emerge their capabilities through lots of these kind of unlabeled data. But not only that is enough, because you need to also have supervised fine-tuning, reinforcement learning with human feedback. And from that, you have billions of parameters trained from trillions of tokens, and very much computationally expensive but powerful. And that is also propelling the idea for multimodal, multitask, and multilingual learning. Now, I'm not gonna go into the details of these models. You pretty much know about this. So, so the language model idea is given an input, then tokenization happens in terms of figuring out like what should be the minimum token that the model would actually learn to predict. And then this is the backbone of the transformer and attention based model with multi heads, and it's basically trying to predict the next token given input. And these are autoregressive models, meaning the generation of the words or phrases or the tokens actually are fed into the network again to predict the next words or phrases. So that's why it's called autoregressive. So that means that if one word or phrase is wrong, then it might lead it to hallucinate. So that's one of the limitations of these models. So that's why these models were not powerful yet until after is trained using language model principles. But once the pre-training happens, then it has to also go through supervised fine-tuning. So there has to be some label data. Some humans have to go through them. Then they'll have to assign rewards and annotate them. So that's the reward modeling. And then based on that, the reinforcement learning principle would be learned to figure out like what should it generate to get the best reward. Now, the idea here, remember, is that the model is actually not a product. So this is like, one of the diagrams for one of the copilots that we released a few months back. My team worked on this. So this is the forms copilot. If you haven't used it, you can use. So you can generate forms in seconds by using, given some prompt and context. So you can see here, the model is only here, right? But it also is surrounded by various guardrails like responsible AI best practices, intent classifier. Then the output is also validated by responsible AI guardrails, and then if it is ready for client-side preview with the UI experiences. So, and there's also robust form prompt templates that are assigned based on the actual intent of the form. So this is to say that model itself is not equal to product. So it goes a lot of effort to wrap it around various services and other models that are not large language model based, traditional machine learning based models that are also used to deploy some product like this. Now, what's the future? So that in the future, what we are trying to do is coming up with small language models. So because we have seen that large language models are expensive, they're powerful, but they may not be needed for all different complex or simple use cases. So they might be useful for many complex tasks. So therefore, we have seen that can we solve the same tasks using small language models? Why? Because they're easier to customize, cheap to develop, and more energy efficient and affordable and accessible. If you want to learn more, you can browse this. So Microsoft is leading in this area with Phi series models and Orca series models. The other big trend is, as I mentioned before, is going from unimodal to multimodal, meaning that from large language or text-based models, how can it learn from different modality of data so that it has more knowledge about the surroundings of the world. So therefore, it should be more accurate in its response. And it also has to be multilingual because it's to support also low resource languages. Yeah, to summarize, the key takeaways for this presentation is that we are progressing fast. This is evolving area, but human feedback is actually not gold standard, right? So as I mentioned before, that the machines are also learning the limitations of the humans, right? So therefore, the key strategies for building generative AI applications is very much starting with understanding the user needs of the problem domain. Right now it's mainly based on lots of prompt engineering, efficient prompt strategies like zero shot, few shot prompting, or chain of thought or tree of thought, measuring and mitigating hallucination or fabrication. Remember, tokenization is the key here, because how you tokenize and what's the vocabulary size, that would also determine the performance of your model. Then is it single turn or multi-turn system? What's the token limit? Because sometimes the models cannot accommodate infinite context. Then how do you incorporate responsible AI best practices and guardrails? So these all come into picture along with the evaluation, and evaluation is the most challenging part here in this kind of models, because depends on the model, depends on the product, user level metrics and feedback. So all come into picture to figure out like how this can help benefit the task at hand. Now, what's happening again? These are the summary as I mentioned before. For the future, smaller model size, model distillation is happening, increased context size and token limits, efficient training and fine tuning. So, for example, parameter efficient fine tuning and low risk attention based models. Then better alignment with asks. So, are we able to understand the user intent properly, right? So that's where retrieval augmented generation is coming into play to augment the knowledge, because the pre-trained model's knowledge is not current. So connection with external tools and APIs for specific tasks. Then domain-specific multimodal, multilingual large language models with personalization, because some of these models are so foundational, so we have to really fine-tune and add personalization capabilities to solve personalized tasks for people. And then other big areas of future trend is in terms of how to automate the model and product development more and more. So these are the supports that we're giving with Azure AI Studio, and within the Azure cloud. So how to automatically summarize or optimize the prompts. Then agent-based architecture is another big area that we're working on in terms of how to decouple the tasks in a way that agents can actually coordinate and solve them. So with shared memory and semantic kernel and autogen are some of the platforms that we built. You can have a look at them. Then enhance analytical reasoning and planning capabilities. And how can we improve the accuracy with real-time user interaction data? Because the users are actually using these copilots, so they should be able to give real-time feedback so the models can actually improve. Now, this is basically my last slide. So how do we envision the future? So OpenAI came up with this recently, some ideas of leveling, that where we are and where we are going. So remember, what we have with ChatGPT in 2022 is basically, having conversational chatbots that are very fluent, coherent, right? So you can really talk with you no matter if it is factual or not. So that's the hallucination limitation part, but it can actually carry on the conversations with you. So that's level one. In level two, we also have seen some progress in terms of reasoning capabilities, human level problem solving capabilities. So that is where we also had some progress recently. Nowadays, we are working closely with you know on this domain in terms of planning and advanced reasoning, agent based explorations, so that agents can actually take action by themselves. So this needs more understanding of the complex tasks and decoupling the tasks into simple tasks. And then level 4 is, can it imagine and innovate new ideas and create new things and invent new things, right? And finally, level 5 is like organizational level scaling, that can it actually run an organization by itself. So it's like super powerful models into the future. So in terms of autonomous machines. So yeah, let me stop there. I hope it was useful, and happy to take it.